Hi everyone. This is an example of a mole to mass style problem, and it brings the situation of solving for the precipitate into the mixture as well. Here we go. Calculate the mass of precipitate formed when 3.59 moles of sodium phosphate is added to barium hydroxide solution. When we have a stoichiometry problem, we're always using these 4 steps. And the first step is balance the equation, interpret the question. We're on the lookout for keywords to help us understand what's going on. Formed, added to. A precipitate is formed. We're going to produce a precipitate. We're going to need to find its mass. That's a wrinkle we have not encountered yet. Sodium phosphate is added to barium hydroxide. Those are the reactants. So we need to do what we need to do to understand the reaction, to wrap our head around it in order to produce a balanced chemical equation. Here we go. Sodium phosphate is added to barium hydroxide. Sodium phosphate, sodium is a 1 plus, phosphate is a 3 minus. Reacts with barium hydroxide. Barium is a 2 plus, hydroxide is a 1 minus. Here we have a double replacement reaction. The cations exchange spots. The sodium is going to get together with the hydroxide. Sodium is a 1 plus, hydroxide is a 1 minus. Barium is going to get together with the phosphate. Barium is a 2 plus, phosphate is a 3 minus. Now we need to balance the equation. Go. That's 6 sodiums, 2 phosphates, PO42, 3 bariums, Ba3. 3 times 2 is 6 hydroxides. Here's our 6 hydroxides, a balanced chemical reaction. As we move forward, we need to calculate the mass of the precipitate. Now, what's a precipitate? A precipitate is the solid product. That's the definition of precipitate, the solid product. So we have 2 products. We need to decide which one is the solid. To do that, we need to go to the data booklet and find the table of solubility and use it in order to decide which of the 2 is a solid. Turns out barium phosphate is the precipitate. This one is solid. And we're trying to find its mass. Calculate the mass of precipitate. That's what we're trying to find. I'm doing it in red. And wherever that question mark is, it's required. A little bit of extra work in order to decide which chemical we were solving for, but one more time, the precipitate is the solid product. How about what was given to us? 3.59 moles of sodium phosphate. 3.59 moles, that's N, and I'm writing it under the sodium phosphate because that's the chemical that it was logically connected to in the wording of the problem. And this is given. When we have a stoichiometry problem, there's some keywords sometimes to focus on. To come up with the balanced chemical reaction, it might take some looking in the data booklet. That's okay. The precipitate is a special kind of situation. It's the solid product. We're going to encounter it sporadically throughout the course of the unit. This is the first example we've seen. This is a mole to mass problem. We started with moles of one chemical. We're solving for the mass of another chemical. The numbers that were given in the question, G, given, whatever we're looking for, R. Now, let's find moles. Are we doing mass over molar mass, or can we find the moles by reading? Boom. 3.59 moles, it's right in the question. 3.59. Now we're going to multiply by R over G. R, the balancing number of what we're looking for, has a 1. G given 2. If we were to stop right now, we would have what I call red N. So all of this represents red N. But this question is not asking us for the moles, it's asking us for the mass. And the mass, it's the moles, red N, multiplied by the molar mass. We are looking for the mass of barium phosphate, so we need to use the molar mass of barium phosphate. It's pretty big. There's 3 bariums. The molar mass of barium is 100. 3 of them, 137.33. I'm double checking. 137.33 plus, that's 2 phosphorus. 2 phosphorus. Phosphorus is 30.97. And that right there is 8 oxygens. 8 of them at 16 each. Really big molar mass, 601.93. So we have lots of calculations to work through. Here we go. 3.59 times 1 over 2 times 601.93. That equals 1,080.46435. Pretty big number. We need to round it off to 3 significant digits because we have those 3 digits in the one number in the question. 1,080, round it off to 3 significant digits. You can see how it's already up and has 4 digits before the decimal. We want only 3. We must use scientific notation. This becomes 1.08 times 10 to the power of 3. This was the mass that we found, grams. When we have to use scientific notation, just remember that the first part must be between 1 and 10. 1 and 9.9 to be more precise. And we can't forget those units, grams. When we have a stoichiometry problem, we're always going to solve for the same 4 steps. Be on the lookout for those times where we're asked for a precipitate. That's where the states are going to matter, and the precipitate, by definition, is the solid product. We're going to have to decide on that using the table of solubility in the data booklet. Also, don't forget that when we're solving for the mass, the molar mass that we're going to use here after the R over G belongs to the chemical that we are solving for. And I hope that helps.